guys, so you just need to sort of listen. Again, I'll post this video up on our Google Classroom once I trim it all up. Okay, this is 3A, and it says differentiate. Make sure I've got the right one. 3A, differentiate sine x divided by cos x. Okay, now if we're going to differentiate something that is like this, okay, so we've got a numerator and a denominator, then use that rule. Okay, remember the rules, which is a quotient rule, says v, the denominator, then we differentiate the numerator, subtract, swap them around. So v dash, leave the u, and then v squared underneath. Okay, so that's what I've used here. I've got my v, which is cos x, that's my v, there's my u. Numerator is always the u, the denominator is always the v. So I've left the v, there it is. I've differentiated sine, being my u, because that's what the rule says, differentiate sine. So when I differentiate sine, I got cos x, there it is. Take away, okay, so I've got the minus sign. Differentiate the v. The derivative of cos is negative sine x. Leave this u as it is, so I left the sine, there it is. All divided by the v squared, so the v is cos squared x. Okay, we've got to simplify that, don't just leave it as it is. This rule you might not know, okay, but this part you'll know, cos x times cos x is just cos squared. Sine x times sine x is sine squared, and two negatives, of course, become the plus. So that's how we get that part there. This rule, that is a specific rule in maths. Cos squared something, we'll call it x, plus sine squared of the same thing equals 1. That is a maths rule. So if you don't know that, make sure you write it down, highlight, remember it. That's how we get the 1 in the numerator here. So I've got 1 divided by cos squared x. Okay. Then it says, and hence find an antiderivative of 1 divided by cos squared x. So now we've got to use the information that we've just worked on to integrate it. So I've written that the integral of 1 divided by cos squared x dx, when we go back, because if I integrate this one, and I'll do it like this. At the moment I've got this d dx of sine x divided by cos x equals 1 divided by cos squared x. That's what I've just worked out. If I integrate this, that's what I want to find, the integral of that. That's the question. Integrate 1 divided by cos squared x dx. I'm going to integrate this. This one, the right-hand side, just becomes the integral of 1 divided by cos squared x. That's what we wanted. If I work this part out, well, if I integrate something and differentiate at the same time, they cancel. So I end up getting sine x divided by cos x. So the integral of 1 divided by cos squared x dx equals sine x divided by cos x. Sine x divided by cos x, well, we know sine divided by cos is equal to tan, so that just equals tan x. Any questions on that one? Okay, I'll give you a minute or so to, if you're copying, I know some of you are copying it down, to copy it down, and then I'll move on to the next question. So this I'm going to be clearing. It will be on video, but I need to clear this to move my page. All right, 5, 4, 3, 2, 1. Okay, it's all going to be cleared, and I'll move to the next page. Okay. All right, this is question 5 from the exercise. It says find d dx, so the derivative of e to the square root of x, and then it says And hence means use that answer, evaluate the integral from 1 to 2 of this function. So let's do the derivative first, okay? Differentiating this, that's what it's asking us to do. So when I differentiate that one, remember this is just x to the power of a half. That's all that is. And you always differentiate with respect to x. So when I differentiate with respect to the x, there's my x to the power of a half. If I differentiate that one, I get my half. Okay, and then I've got to take away 1 from the power. A half, take away 1, which gives me negative a half. That's how I get that part there. Okay, so a half, x to the negative a half. E to the square root of x still remains, because remember, when you differentiate e to the x, it still remains as e to the x. So we've still got e to the square root of x. And then I've just simplified that. Okay, so this x to the negative a half goes down the bottom. Okay, so it becomes the 2's down in the denominator, the x to the power of a half, which is just the square root of x, that's down in the denominator, and this e to the square root of x is just up the top. Any questions up to there? Okay. Now the next part says, hence, evaluate this. Okay, well we know, okay, we've just worked this out, that if I integrate this now and put an integral there, then I know that I've got the integral of this thing between 1 and 2 is the same as the integral of that thing. Okay, so there it is there, I've written it here. The only thing is I've got to take out this half because there's no 2. So you can see there's no 2 in this question at all. So this 1 divided by 2 has to come out. So I've taken it out. That's just a constant. That's all that is. It's just a constant. Okay, so I'm using this answer. And I've written it there, but I'm taking out my half and the rest still remains. So I've got the half out on the outside, the integral from 1 to 2 of e the square root of x divided by just the square root of x, because the half is outside. Is everyone happy there? Okay, now I know that this part here, okay, this part here, all right, will be, well, sorry, this whole part will be e to the square root of x, that whole part. But of course, I've got the half in front. So I end up getting, this half is going to come at the front. So let me do it like this. A half integral from 1 to 2 of e the square root of x divided by the square root of x dx equals e to the square root of x, because we know that through this, between 1 and 2. But this has to move to the other side. So divide by 2 becomes times by 2. That's how I get my times by 2 there. Can everyone see that? Any questions before I move on? Okay, so this divide by 2 here goes to the other side. Of course, divide becomes times. That's how we get the times by 2. This part, e to the square root of x, was from the previous part. Okay, so now we substitute our 2 in. So we got e to the square root of 2. Substitute our 1 in, e to the square root of 1. Remember, we always minus the 2 when we're doing that. And we simplify. So I've brought the 2 back in, 2 times that and 2 times that. That's how I get 2e to the square root of 2 minus 2 to the power of e, because square root of 1 is just 1, and e to the power of 1 we don't need to write. You can put e to the power of 1 there, it won't matter. If I can get my hands steady. Okay, it won't matter, you can leave it without, because e and e to the power of 1 are exactly the same things. Any questions? Now these type of things is called integrating by recognition. So integration by recognition. We are recognizing the fact that if we integrate this and integrate this, they're just opposites, using that fact. Okay. All right, I'll give you about a minute to ask any question, copy anything down, and then I'll move on. Okay, I'm going to clear it in about 10, 8, 5, unless someone tells me not to clear it, 3, 2, 1. Okay, let's move on. Now we can, of course, do this on the calculator. Okay, if you see on the calculator, all you need to go is to your integral sign. So go to calculus, go to integral, type in your equation exactly as it is. Okay, just type it in exactly as it is. And I forgot to do my annotate. And when you press your enter, it will give you the answer. Okay, same thing here, just type it in exactly as it is, press enter, and it will give you the answer. Okay, that one should be pretty easy for you.